sklearn, linear model, quantile regressor. Description: the quantile regressor is a linear model that predicts the quantiles of a target variable, allowing for the estimation of confidence intervals and uncertainty. It is based on the concept of quantile regression, where the goal is to minimize the sum of the weighted absolute errors between the predicted quantiles and the actual target values. Inputs: X-A2D array representing the input features, Y-A1D array representing the target variable. Outputs: predictions: A1D array containing the predicted quantiles for the given input features. Steps: the quantile regressor uses a linear model with a penalty term, e.g., L1 or L2 regularization, to minimize the weighted absolute errors between the predicted quantiles and the actual target values. During training, the model learns the coefficients for the linear model, which represent the weights assigned to each input feature. For prediction, the model uses the learned coefficients and the input features to calculate the predicted quantiles. Metrics: mean absolute error measures the average absolute difference between the predicted quantiles and the actual target values. Quantile loss: a specialized metric for quantile regression that measures the deviation from the target quantile. Visualization plots: quantile QQ plot visualizes the distribution of the predicted quantiles against the actual target values to assess the model's performance in capturing the desired quantiles. Residual plot plots the difference between the predicted quantiles and the actual target values to identify any patterns or systematic errors. Fine-tune parameters: alpha controls the strength of the regularization penalty. Higher values lead to stronger regularization, potentially reducing overfitting. Solver specifies the optimization algorithm used for training the model. Common options include LBFGS, liblinear, and SAG. Quantile specifies the quantile to be predicted. For example, 0.5 corresponds to the median, 0.25 to the first quartile, and 0.75 to the third quartile. Uncertainty methods: confidence intervals based on the predicted quantiles. The model can provide confidence intervals for the target variable, representing the range of plausible values. Challenges and fixes: Challenge 1: overfitting to the training data. Sample use case that resulted in challenge 1: when the training data is small or noisy, the model may overfit, leading to poor generalization performance on unseen data. Fixes to challenge 1: increase the regularization strength, higher alpha, or use a different solver that is less prone to overfitting. Challenge 2: difficulty in capturing complex relationships between features and the target variable. Sample use case that resulted in challenge 2: if the relationship between the features and the target variable is highly nonlinear, a linear model may not be able to accurately capture it. Fixes to challenge 2: consider using a more flexible model such as a nonlinear model or adding more features that capture the nonlinear relationship.